Hi guys, welcome to my channel, and today we will be reviewing all about metals in material science, what you can know about metals. So let's begin. Here I have organized my notes and we will start the topic. So let's first start about metals and steel as well, because they are considered one topic. Okay, so metals are arranged in crystal lattice. So it means they can have structures such as FCC, BCC, HCP, and just for the general information, let's just give example of BCC structure. We can open it as basic cubic structure, and it's basically when you have a cube, the atoms are arranged in a space in such lattice. Okay, and in FCC we have same arrangement. The only difference is that we are gonna have in the middle one more atom that is going to connect, and so on. Okay, so these are the differences. Then we also have bonding. We have a thing such as metallic bonding, and why metals are able to conduct electricity. Because we have free electrons floating around. Like in metallic bonding, if we illustrate sea of electrons, how is it going to be? Let's say we are going to have an iron here. Okay, let's say, and we have like tiny electrons floating around everywhere, and due to them floating around, they can basically conduct electricity. Okay, so key properties of metals are that they can conduct electricity and heat. They are ductile. So what the word ductile means? You can basically stretch a metal, right? But we will also learn about if we add too much carbon, then we cannot stretch it anymore, because if carbon is too high, then it can become brittle. And soon when we will learn about iron blast furnace, like how to get a metal, how to produce a metal, we will learn that we will get pig iron as a result, and the carbon percentage will be high, so therefore it will be brittle as well. They are ductile, can stretch, and they are malleable, which means we can shape them. So you saw that we can shape them into thin like electric conductors, and they can be strong, but it depends on structure. So how do we make metal? So we make metal from ore. Ore produces metal, and we have iron ore, then we have coke, and we have limestone. When we combine these three things under the blast furnace reaction, then we can get iron, we can get metal as a result. Okay, so iron ore formula is like this, or it can have such formula, And coke consists of carbon, like fuel plus reducing agent. And then we have limestone. Limestone actually removes impurities. Okay, so when we combine them in a reaction, our output is pig iron, and the carbon percentage is quite high, around 4%, which is not quite normal. I mean, it's normal, but it's not quite good. And we also have slag. So this is basically a waste. But the pig iron is not something that we can use, again, because I mentioned before that it is quite brittle. So we have to refine it. So we have to reduce carbon and control composition as well if it has any impurities. So what do? We have basic oxygen furnace. So before it was blast furnace, and this is basic oxygen furnace. So what do? We blow pure oxygen. We blow pure oxygen into the molten iron. And what happens? Basically, it removes impurities. And our result after blowing the pure oxygen, from pig iron we have steel. And composition of carbon is from 0.02 to 2%. Okay? And then we also have electric arc furnace. Electric arc furnace. It basically uses a scrap metal. Electric arc melts metal, making it more sustainable. We make metal more sustainable. Okay, so then we have heat treatments of metal. So what do we have in heat treatments? We have annealing, we have quenching, and we have tempering. Annealing, quenching, tempering. And what are the differences between them? So when we are doing annealing on a metal, we basically heat it and then we slowly cool it. Okay, that's called annealing. And our result is soft and ductile metal. When we do quenching, we again heat it, but we cool it rapidly, fast. So let's say from sudden high temperature, it goes into sudden low temperature. So our result is hard and brittle. We get our iron hard and brittle. And lastly, we have tempering. It is basically reheating again after quenching. It reduces brittleness, okay? And then we also can shape the metal. For example, you can have a metal table, let's say. It's been shaped, right? So how do we shape the metal? So first we have casting. Casting. What is casting? Casting is from liquid to solid. So what do? We melt metal, we pour it into mold, and then we solidify it. We wait till it solidifies. But there are some problems when we do it. Since we pour it into mold and it happens all very fast, we have problems such as porosity. So what is porosity? Have you ever seen like inside the some structures we can have like little pores existing, and the air can come inside of those pores. So it is not good for a material. It makes it weaker. And then we can also have cracks, or we can have shrinkage. So this is cons of casting, but the pros are it's fast and it's cheaper. And the second method of shaping, we have forging. It's slow, it's very energy consuming, but it is more quality result. It gives us more quality results. So what we do, we apply force and we reshape metal by force. For example, we can hammer it. We can hammer it and we can physically reshape the metal, and as a result we get stronger material. But one question we should ask ourselves, why properties in metal can change? As I mentioned before, metal can be strong, but it depends. So what is the thing that makes it change? So we have such thing called as dislocations, that is defects in crystal. And when we so basically the result of dislocations is when we move the material, the deformations form, okay? And we have strengthening methods. So how to strengthen so that we do not have dislocations? We can do alloying. So what is alloying? We can add another atoms. We can do work hardening or heat treatment. So these three methods, they can use to strengthen the material and reduce the amount of dislocations, because they are basically defects in crystals. Okay, moving on. Metal itself consists mainly of metallic elements. So what are the metallic elements? We have, let's say, iron, aluminium, copper, silver, gold, and so on. These are our metallic elements. But the thing is, most materials are not 100% pure. So we call them alloys. Alloys, it's like when metal is mixed at atomic level. By the way, it's very important. If they are not mixed at atomic level, they are not alloys, they are composites. So alloys is when we have one main metal and then we have one added element. So for example, we have here iron, right? And I think it would be better if I draw it differently. So we have here, yes, iron, let's say. And the small carbons here are basically the one added element. So this is an alloy, okay? This is an alloy. You can see that it's mixed on atomic level. But composites, as I've mentioned before, composites, they are mixed at micro or macroscopic level. So what it means, materials, they remain physically separate. For example, we have concrete. We have cement plus sand, cement and sand and gravel. Or we have fiberglass, it's polymer plus glass fiber. They are mixed on a physical level, but not on atomic level. And we have two kinds of alloys. We have substitutional alloy and interstitial alloy. So substitutional alloy is when solid atom replaces host metal atoms, you see. So let's say these are hosts, and let me add another color, and this is the another atom, like added element. It replaces the host metal atom. But interstitial is when we have our host metals, and in the small gaps between them we fit our alloys. Let's say, like, as I've mentioned before, as I showed before, this is the interstitial alloy. Okay, so then some properties of metals, as I've mentioned before, that they have good electric conductivity because they have free and delocalized electrons. Then they have good thermal conductivity. They are ductile, malleable. Then they have something I didn't mention, they have lustrous appearance. So it means that when we shine light at them, they shine it back. So we can observe that they can be shiny. And some are magnetic, depends on electron arrangements. One thing is that metals can be magnetic only at certain temperatures. Magnetic at certain temperatures. So let's say you have a metal and you want to stick something and it's magnetic, right? And then you heat the metal and you cannot stick it anymore. The magnetism disappears. But if it cools again, then the property will return. And they are opaque because they are free electrons. So lustrous appearance, we can also call it opaque. They are free electrons. They interact strongly with light. When light hits metal, some light is reflected and some energy is absorbed by electrons, so light can't pass through easily. It returns at you. Okay? So when dislocation, as we mentioned before about dislocations, when they move, dislocation, movement, we can have plastic deformation. And if they can move easily, metal bends easily as well. And if dislocations they can't move easily, the metal also becomes stronger. Then we have ferrous metals and non-ferrous metals. So ferrous metals is when iron acts as a base metal. But non-ferrous metals, they don't use iron as a base metal. They can use aluminium alloy, copper, brass, and so on. Okay? Iron is very important. Iron-based alloys are used in buildings, bridges, cars, machines. And we have steel. These are both ferrous. Okay? We have steel and cast iron. So steel has 0.02 carbon composition till 2.1. It's strong, tough, formable, and useful for structures. But cast iron has higher carbon composition from 2.1 to 3.4. It is hard, brittle, and good for casting, compression, and compression strength, but it has poor ductility. Okay. So now I will tell you more about blast furnace. How does this process happen? Blast furnace. So we have iron ore, we have coke, which is mostly carbon, acts as fuel and reducing agents, and we have limestone, right? Iron ore, coke, and limestone. So what do? We have a hot air blast. It provides oxygen for combustion. So what we have as a products, we have pig iron, as I mentioned before. It is molten iron, high carbon and carbon high as 4%. And we have slag. It's waste impurities. But what is in the slag? We have mainly calcium silicate as our waste. And we also have gas. So we can have carbon dioxide, nitrogen, carbon monoxide as our gas. So it can be bad for human. We cannot approach when it happens. And also we have argon gas bubbling. So what is argon gas bubbling? So argon itself is inert. It does not react easily. So in steel making, argon can be bubbled through molten steel to stir molten metal, to mix alloying elements evenly, to remove dissolved gases, and to improve uniformity. So why argon? Because argon doesn't oxidize metal. This is why we use argon. So we also have such thing as adding alloying elements. So what elements mostly are added during alloying? So we can add carbon. If we have carbon, our hardness and strength increases. But if we add too much carbon, we can make it brittle. We can make steel brittle. We can add chromium, improves corrosion resistance in stainless steel. Corrosion resistance is getting higher. Then we can add nickel. Again, improves corrosion resistance and adds toughness. And we can add manganese, improves strength and helps remove sulfur. Okay, so how do we have stainless steel formation? What is stainless steel? So contains chromium, usually at least 10.5% made of chromium, so pretty high amount. Chromium forms very thin protective oxide layer, prevents further corrosion. Then we have rusting mechanism, is the corrosion of iron. So rusting itself requires iron, oxygen and water. So that's why if we have, let's say we have a chromium as a thin protective oxide layer, it prevents corrosion because it blocks oxygen from entering. And then we have such questions such as why salt water increases corrosion? Because salt water contains ions. They increase electrical conductivity of water. They speed up electrochemical corrosion. And acid as well. Acid contains hydrogen plus ions. They help corrosion reaction happen faster. And acid can dissolve protective oxide layers. So ions, they increase electroconductivity and they speed up corrosion. Then how do we prevent corrosion, right? How do we prevent corrosion? So first we can do alloying. We can, as I mentioned, we can add chromium to form stainless steel. What we can also do painting. We can do painting. Painting forms barrier between metal and environment. Then we can do polymer lining. Polymer coating prevents water, oxygen, acids, and salts from touching metals. So it is protecting. And then we have galvanizing. When we coat it with zinc. Zinc sacrifices itself to protect iron. So iron does not rust, but zinc rusts in galvanizing. So that's why we coat steel with zinc. And then we have cathodic protection. So what does it mean? We can make the metal act as cathode, so it doesn't oxidize. Okay. Then what we have is that we have iron-carbon phase diagram. Iron-carbon, or we can call it iron carbide diagram also. We are going to explore this further in the second part of the video because it is itself a huge topic. But this was metals for now. I hope everything is clear about metals. See you in the next video.